Okay, so let's get started. Um, like I said, in this class we're going to edit this cube to turn it into something interesting, and it can be different objects that we can build from here. And I'll start with this podium over here. And did we do the podium in this section or the other one? Did we build a disc or this thing? Okay, so we can try this podium over here. See, previously what we did is we selected this cube and edited the geometry, like we scaled it in the z-axis to make it flat, right? If I wanted to build this top surface over here, I'd have to squeeze it down in the z-axis. That's one way to go. However, it's going to be much easier if I get direct control on the geometry, and we can do so just by going into the edit mode. And now we got this surface over here, which we can select all four corners and then move it up just like that. Okay, this is not scaling, this is just editing the geometry of it, and you can make it as thin as you like or as thick as you like, depending on your needs. You can edit that. We're editing the geometry. And in just the last lecture, we also talked about the cut. So we can introduce the cuts to bring it out this part, because this is going to be slightly smaller over here to start with. Now, before I do that, I could definitely use cuts. Like I can place a cut over here, I can place another cut over here. Okay, I could cut it out like this, but without even doing that, let me show you another really simple technique that we can use to bring out a part right from the middle. So first of all, let me show you how we can extend a part of it with extrude, E for extrude. Okay, so we can go for face selection, like E for extrude. Um, right, if I select this face and hit E, we can extrude that. Then we can extrude from here. We can also extrude from here. And you can go crazy like this. Okay, so you can select any face and bring out new geometry right from there. See, we started off with a cube, but we can now change that in any way we like. And this is not just about the face. We can also go with an edge. We can extrude that. Okay, or you can also go for a vertex. You can select a vertex, E for extrude, and keep on drawing like this. Okay, which is again probably not something we need right now, but I just wanted to show you that there are selections down here that lets you work with a face or an edge or a vertex. So first of all, since I wanted to build this part, the top surface is done. I wanted to build this part down here, this whole thing, and we have a slight indent that we need to probably scale this down, make it a little bit smaller, and then extrude from there. How do we do it? This is easy. E for extrude and S for scale, and then you can bring it inward. See what that did? It cut off parts from all four corners, and now we can hit extrude and go down. And we can adjust that. Do you see where I'm going with this? Rather than cutting it out from four different corners, now the shape looks like this, that we have quadrilaterals from all four sides. Okay, and right in the middle we got a structure like this. Okay. Then what we need down here are four legs. So what I would like to have over here is some sort of cut so that I can extrude from here. That's the idea. Okay. But that doesn't come for free. We have to introduce cuts that goes all the way till this point. Like we have to come up with a cut that goes all the way and over here again. We have to cut it up like that so that we can extrude from four corners. If you want to make it a single piece, that is. So right now we can introduce this cut and we can bring it down, okay, till this point, or we can go and slide it over to this point. Now these things are better done with measurement. Let me just do it by eyeballing this for now, but we will go with proper measurements in a bit. And one thing I want to do before I do anything else is I want to switch from perspective view to orthographic view. And you can do so if you go to the view menu. There is this option view persp or ortho. The shortcut for that is number pad 5. So this is the orthographic view. I can also switch between the top view. See, this is how it looks like right from the top. Okay. Or I can go for the bottom view. This is how it looks like right from the bottom. Or I can look at the front view. Is this thing clear? It would be handy if you memorize all the shortcuts for switching all these views. 1 is for front, 3 for right, 7 for top. Okay. To get the opposite views, you just hold down Control. So for example, right now this is the top view. That's with number pad 7. To get the bottom view, Control 7 will get you the bottom view. If 3 is for the right view, Control 3 is for the left view. Yeah. 1 is for front, Control 1 is for the back. So Control 7 like this. So what I'm saying is that I'm going to introduce loop cuts. So one cut will be over here, another cut will be over here, and then two more down here. So let me just eyeball these things for now. Like, I'm not going with exact measurement, that's what I mean. And another one over here. Then we need one over here. And one down here. So with those four in, you see how it looks like now. You can go for face select mode. This one, shift select this one, shift select this one, and shift select this one. We have selected all four corners. Now things will be really very easy. E for extrude, go down, and that's almost our podium. Okay. There are a few things left, like we have joining bars like these on the side, on the back. We can do that. So let us go look at the front view. This is the front view. We can go for the back view because I wanted to introduce a bar over here. So what I can do is I can hit Ctrl R to introduce a loop cut, and I can bring that down somewhere over here. Another loop cut maybe over here, a loop cut here, another loop cut over here. And once you have these in place, all I need to do is to join them together to form a bar. You can imagine that I can select this face, E for extrude, bring it over here, and then try to join that. That's one way to do it. But let us learn something new. I can select this edge and also this edge and then join them together to make a face in between. The shortcut for that is F. F for face. Okay. So when we do this, we need to select this edge and select this edge, press F to make another face, the one down here and one over here, that should be another face, and finally these two, they need to be joined together to form a face. Is this thing clear? Okay. So similarly, once you have this ready, we have bars on the side as well. Like the one that I just did was this back one. That was the back face. We need one over here, another one on the other side. So again, a loop cut, if you bring this down, another loop cut over here. So once the loop cuts are in place, select these edges, not this one, and introduce a face. And over here, we are going to introduce, I can't select things. We can introduce another face. Okay. Do you understand the workflow, how we are doing things over here? One thing looks a little bit odd over here is because the shading of this is really dark. But if you look at this one, it's pretty bright over here. It doesn't really match. So in order to understand what happened, we need to enable the surface normals. So if you look at this, the surface normals of these faces, they are properly sticking out. However, for that plane that we introduced over here, it didn't work right. The surface normal is going inwards. Okay? Let us try to fix this thing into two different ways. Let me delete this face. If you hit the delete key, you can delete face, you can delete vertices and all that. Let me delete this face and let me try to add this one more time. See, it doesn't work. If I go from here to there, then it works. It's kind of interesting that for the same face, if I join this edge and this edge and form the face, it looks right. But if I do it the other way, it doesn't look right. Why so? It's again based on right-hand rule of vector cross multiplication. Okay. So the reason this surface normal will come out is because we have vector A and vector B. So if you do a cross product like this, your thumb will show where it's going to go. But if you go the other way, that you take this one and then this one, then it's not going to work properly. Let me try to make it a little bit more obvious. And for that, I want to select the vertices manually. So this vertex, this vertex, this vertex, and this one form a face. It looks right. What did I do? I went counterclockwise. This is counterclockwise, right? However, if I go clockwise, let me take off this edge, select these two, this one and this one, and then form a face. No, well, again, this one worked as well. Okay, yeah, that's kind of strange. I'm going clockwise and it still works. So maybe Blender understands that. It's just that when it works at a face level, it doesn't, edge level, it doesn't work. So this edge and this edge, if I join them, they work. these two. Now they started working in all the cases. It's kind of strange. However, we still got a problem for these two ones, right? The surface normals, they are going inside, not outside the way they should. So there will be many different scenarios where you join faces like this. Sometimes they will work and sometimes they won't. Let me try to finish this off. See, this is again wrong. This one is wrong again because these surface normals, they should be sticking out. So there is a very nice feature in Blender where you can select all the faces with A and hit Ctrl N. Then all these surface normals, they will be pointing outwards. Okay. So if you're working in the edit mode and if you're creating new faces, sometimes you'll see that the face is normal, they're not looking right. And how do you know that? You just enable this normals to have a look at it. And you can also understand that just from the shading of it. So once that happens, you need to make sure that they're in the right place. So hit Ctrl N after selecting everything. Is this thing clear? Okay. All right, so let us do the other one. So we got these two, and I'm going to join the vertices, the edges together to form a face. These two over here, and this one over here. Finally, these two vertices, and again you can see that none of the normals are right. So A for select all, Ctrl N for fixing the normals. Okay. Now I made a mistake on purpose. As you can see that the from the other side, this will probably be more obvious. Well, from over here, see, this is wider compared to this. They're not of the same width. Okay, and that's a problem. You need to line them up, otherwise they're not going to look good. So how do we fix this? See, all these edges that we got, we need to select them. Okay. So all these edges that need to be aligned together, we need to select all of them. Right over here and over here. And any of these things that you may find, we can move them together to make sure that they're aligned right. It's a little bit tedious, but you need to get it right. Okay. Maybe I'm almost there. Yeah, looks okay. Alright, so I went around for the entire object and selected all these things. And what I really wanted to make sure is that they are of the same Z value. Okay. So there are quite a few different ways of doing this. So if you go up there with your properties tab open, let me zoom it up a little bit. In the properties tab on the top right, it tells you the Z value. And the Z value that you see is the average Z value of all these things that are selected. So if you come with one number like -1, okay, then you can change that, or say -1.2. So it's going to change the Z value for each and everything. Okay, but you can still see that there is a slant. There is a slant like that. So they're not balanced together. So that's a bit of a problem. I mean, you can't really fix this in this way. That's why you need to scale them in the Z-axis. See, if I scale them in the Z-axis, see, this creates further imbalance But if I scale them on the z-axis by 0 units, then they're all flat because there is no imbalance in z anymore. Is z0 that fixes this problem. That will balance out everything, that will flatten out everything on the z-axis. Okay. Similarly, maybe the bottom part is not aligned because we did that by hand. So we should select each and every edge over here. So all these edges I think I got them all. Oh, thanks. Yeah, missed that bit. So again, SZ0, there was a slight change, which is quite important to get it right. So once this is done, I have it properly scaled. Now, the interesting thing is that if you select it in this way, you can actually slide them down or move them up like this. If you need to change the width of it, it's in your control, and you can make it thinner or thicker depending on your need. Is this thing clear?
Yes, sir.
Okay. All right. So the last thing we need over here is a bar that joins these two sidebars. Okay. And this is actually on top of these two bars. So we're not going to cut them over here and join them through like this. We'll still cut them. Let me cut them first. Okay. So I want to cut them over here, and I will bring it over here, this one over here. These two, sorry, I tend to forget this. So let me do it one more time. What I'm going to do now is I will cut this apart, and I will slide that closer together over here, but they need to be aligned. So I need to select all these edges. There is a shortcut in Blender. If you want to select all the edges in a loop, Alt Shift right click will do that for you. Alt Shift right click. Let me do this one more time. Alt Shift right click. You see that everything in a loop got selected, and Alt Shift right click over here. That selects all these edges, so that I don't have to go across all these faces because that's in a loop. This is only if you want to select stuff in a loop. Okay. So what I want to do now is I want to align them on the x-axis. Any guess what I'm going to do here? See, the problem right now is this is wider compared to this. I want to bring them together on the same line. What should I do? S? Sx0, because this is happening on the x-axis. Sx0. See, they move together, and now this is right. Okay. Again, to finish this off, I need to select this face and this face. We need to extrude that, bring it up a little bit, and now we can join them together. Okay. This face and this face, we can join them together, but we have to do that edge by edge. So these two edges, join them. This edge on the side with this edge on the side, join that. The surface normal is not right, but we will fix that. This edge over here along with this, and these two. Okay, so two of these faces, they're not right, so select all, Control N, and we are done. A few more details, like if you look at this bar over here, this is not really a rectangle, it has a roundish shape. So it has a bit of a bevel. That's not really a problem. We can select these two things. That's on my y-axis. SY for scaling it on the y-axis. I can make it a little bit slanted so it's not as obvious like that. And that's our little podium built from a single cube. Is this thing clear? Okay. There are a few more things to do if you're going for details. Like right over here, we got a drawer, so we can cut this part open and insert a drawer over here. How would we do that over here? Any idea? We can use loop cuts. All right. So we can introduce a loop cut right here, and the way it is, this drawer, we don't have any gap over here. It's right at the top surface, right? So I was just looking for that. Otherwise, I would introduce another loop cut over here. We don't need to do that. What I need to do is I want to get rid of this face. Okay. How do you delete a face? It's simple. Just hit delete and delete the face. So that's that. We have a hollow right in the middle. So this is how it looks like. Now it creates a problem right over here. If you delete the face like that, it creates a problem because, see, we have really thin edges. It looks like paper. There is no depth. I mean, if it were built with wood and everything, like we'd have a face here to hold the drawer. Like if I take out this drawer altogether, there will still be faces right there. I can do this. I can take it apart. So if we look at the hollow, it doesn't look like paper because there is wood all around, right? There is a base to hold this thing, this drawer. So how do we fix this? How do we make sure that there is something solid to hold this over here rather than deleting this? Okay, so I undo all these steps and now we have this. The easiest way to go about it is to extrude this inwards. Okay, so E for extrude. Let me select this again. We're going inward in the X direction, so E for extrude, and let me push this in, and that will create that hollow thing right in the middle. Okay. Let me do this one more time, but with the wireframe view, not the solid view, because as I move it inwards, there is no way for me to tell how far in I am. So E for extrude, if I go inwards, now I can see exactly where I'm going, right? So maybe I want to stop right there. So once we have this in place, see, now we have a nice little hollow right in there. That gives us a space to build a drawer right here. Is this thing clear? So the next obvious question, how do we build a drawer? And for that, I'll say that this is not going to be built from the same cube. It has to be made separate because we're going to probably animate this or let the user interact with this. Someone will pull it out. If it is made from the same cube, then when we pull this out, it's going to destroy the geometry of the whole thing. Like if you select this thing, if you consider this to be the drawer, and if you try pulling this, it's going to destroy the entire geometry of it. So we don't want that. We're going to make it from a separate object. That's why you come out of this edit mode and add another cube, for example. It's just that we have to make it smaller, which is quite obvious. So let us scale it down first of all to fit the shape. And it's probably easier done from the front view. Actually, I made a mistake. This is done from the side view. Alright, so no big deal. So from the side view, I need to make sure that this is of the right size. And probably you're not going to see this quite clearly from the back. So let me draw the hollow part for you. This is the hollow part. And this is the big cube. So I still need to scale it down so that it fits. Let me make it a little bit smaller on purpose. Now once I have it in place, I can move this over here and then go into the edit mode to select this face. And then put it right up there. So when I go into the solid view, you can see that we have something new. This is the base shape of the drawer, which we can pull out like this. Well, not like that, like this. Okay, it doesn't really look like a drawer right now, but that's all right. We can introduce loop cuts to cut it open, give it the exact shape, also give it a handle, which I'm not going to cover right now. But that's easy stuff. I mean, it gives us the control to slide it over out like this, or to push it in. We'll put some sort of barrier so that it doesn't really go inside. But with that done, let us try for a render. That's our podium. Okay. Or we can do something better. If you press 0 on your number pad, you can select this view and lock camera to view. If you have this option checked, holding down shift and placing it properly, and then we can go for this render. Looks slightly better. It's just that our light is not in the right place. Maybe I want to bring it down some more. Okay, and also add a few more lights. Excuse me a little bit. Hello. একশো 2 নম্বরে একটু ট্রাই দেখেন আপনি করতে পারেন আর যদি না হয় তাহলে আমার অথবা সার্ভিস পাঠাতে পারেন আমি ক্লাস শেষ করে তাহলে দেখবো আর কি Sorry about that interruption. Okay. So me doing the whole thing over here wouldn't really work. So at this point, I will transfer it over to you guys, so you can try and build something similar from a cube using loop cuts, extruding stuff, joining faces, fixing the surface normals, and everything that I've done over here. Can we do this?
Yes, sir.
Okay. All right. So before I hand it over to you, let me just talk a little bit about the 2 upcoming assignments. One will be based on what we're doing right now, and shouldn't be too much of a problem. So let us just write it down. So the first Blender assignment is going to be about okay, I want you to design lab 6. Okay. If we can design desks or podiums like this, we should also be able to design the computers. They're not really that difficult. It's a flat monitor type thing, all-in-one PCs. The mouse, well, it's a little bit difficult, but I don't want exact shape like you. If you can't do curved surfaces, try to do as much as possible, like introduce new geometry and then edit them in some way. The keyboards, you don't have to design each and every one of those 104 keys. Okay, but just leave a outline of the keyboard, like make it a rectangle. If you have got more time to spend, then yes, you can go for the keys if you want to do that. But the idea is that the whole task is not really that difficult. If you can design one computer, you can copy paste that. We learned how to do that in Blender. Shift D, right? Select an object, duplicate that with Shift D. So you can make 30 copies of that, place them together, and go for the right format. So what I want you to do is to visit room number 1002. We got a new lab in there. And take some photographs, take some measurements if you need them, and then design the whole thing in Blender. Okay. That's a good question. I'll show you that right away. Before I forget, let me stress that this is an individual assignment. So each of you have to work alone on this thing. Coming back to Masood's question, it's an important one. Let's say I want to design this lab, and let me do this here. Let's say I measured the room and found out that the room is like 20 feet by 18 feet. I'm just giving random numbers. I didn't really measure that. Okay. So how do I design the room to start with? Because everything will be put in the room. What I can do is I can go and insert a plane. Okay. And this plane, as you can see, it is 2 units, not 2 feet. It's 2 units over here and 2 units over here. It's 2 by 2. Okay. So if I wanted to build something that's 20 feet across and 18 feet like this, I need to scale this thing. How many times? 10 times over here on the x-axis. So SX10, 10. And if you count them, so each of these boxes, they're 1 units long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 over here and 10 on this side. So the same thing goes over here. If you want to scale this, so let's say SY 9 times. So this is going to be 20 units this way and 18 units that way. Okay. Once you have this in place, the next thing is to build up the walls. So we can go and select all these edges and bring up the walls. Okay. Now since we're designing this whole thing, I mean, yes, we can build up walls on all sides. Okay. but it's probably easier also in terms of rendering to build walls from 3 sides or 2 sides, because you need to show the whole thing, right? What I'm saying is that if I extrude this now on the z-axis, I can get a box like this. However, when I place the objects inside, I won't be able to see them because there are walls on all the sides. So rather than doing that, we can do what the architects would do. They will pull out the walls on 2 sides or 3 sides, something like this. So in that way, when I place something like a cone in the middle or a monkey, I can still see them. Is this thing clear? All right. So and the other thing is when I'm extruding this, I will have some measurement, right? That this wall is probably 10 feet high or 5 feet high. So whatever it is, like I can press that number on my keyboard and it will stick to that. So this is just 5 feet. So if I try extruding this to 10 feet, for example, I press 10 on my keyboard and that's 10 feet high. Or 10 units high. I mean, I'm only talking about feet for no reason, but that's the idea. So this is for measurement. Like if you're building the desk, the same idea goes, that you can say how much you're going to extrude, how much you're going to scale. You can use the numbers on your keyboard to make it exact. Okay, so once that you have the base floor, the walls set up, you can start placing all these little desks and everything. And what I would advise is if you want to design everything in one layer, then things will get cluttered. Rather than doing so, let's say I build this room over here, I can go to the other tab, all these things. You can do that in object mode. So I can go over here and I can select this thing along with the drawer and hit M for move and move it to the final layer where I am composing this scene. See, it's not placed in the right spot, but now I can place that. But if I wanted to design everything in this place, it's going to be difficult because I can't move around. Like when I'm here, this wall is obstructing my view. So as far as designing goes, I think it's easier done in separate layers. So for example, when you're designing the monitor, you're going to do it in another layer. When you're designing the keyboard, maybe you're doing it in another place, but you can bring them together and finish up the computer. Once the computer is ready, you can put it on the desk and then put the desk inside the room. Okay. So this is just about taking advantage of all the layers that are available to us. To move an object from one layer to another layer, the shortcut is M. M for moving. Okay. All right. Let us talk about deadline. I mean, I'm only talking to this section. I still need to give the assignment to the other section, so that's going to be on Thursday, tomorrow. And there is a big chance of disturbances. We're not shutting down the university. There is no official news on it yet. So I'd assume that university will stay open. If it is not, then that's another story, and we will get to know about it. Say what? The deadline, I want to set it for 17th of February. Is that okay? Yeah, that's more like 10 days. There will be plenty of these assignments coming your way. Like I planned for, I think, 6 of these individual assignments. Okay. Alright, so you'd have to submit the blend file through our classroom. So I'm going to announce this as an assignment. So you get to upload your work, and you'll also get notification as the assignment is coming closer. Also, when you upload your work, you can send in revisions as much as you want before the deadline. Any question about this one? No? Okay. All right, the first programming assignment. This is not going to be about OpenGL. This is going to be a simple one, but it should get you thinking. Like we talked about the OBJ file. So your task is to read simple description of objects and create OBJ files accordingly. Okay. So what I mean by that, let me show you right away, is that let's say we will have a text file. And over here I will write cube 2. That means that you have to make a cube which has sides of 2 units all around. Your task would be to create a file containing all these lines. You have to calculate what would be the vertices and how you join the faces. Yeah, the unit may change. So let me be a little bit more specific. These are easy. Cubes and cylinders are really easy. They're very regular shaped, so you can calculate that. Cubes, cylinders, and let us go for something a little bit more challenging. And helices. The last one probably you're not familiar with. It's like a spiral that goes on and on. I want to go for the geometric shape. So this is a helix. It's like a spiral that goes on curling like this. What I want you to do is to form a tube that looks like a helix, goes on like that. Something like this. Okay. So as you can see over here, this can be generated by computer graphics because you can join together a lot of polygons to make this cube, and it needs to just spiral around and go up. So over here, the parameters would be length of a side, right? For a cylinder, what are the parameters? First of all, the radius of the base and height. With these two things, we can make any cylinder. For a sphere, that's just the base radius. For a helix, I will keep it simple. We will have a fixed height, that this is going to be the total height of the helix, and then we will have the inner radius and outer radius. So See, over here, this is like a circle, so there will be a radius. That's the outer radius. But if you want to form a tube, you want to say how thick or thin the tube is. So there has to be an inner radius as well. And the whole thing will have a height. That's what I'm talking about. So yeah, that's that. So only number 4 is difficult. Number 3 is not so difficult if you consider a sphere like our Earth, that we are going with the longitude and latitudes. We know about longitude and latitude, right? We studied that in geography. That allows us to think of the Earth in terms of angles that goes across like this, and we can also slice it open. Okay. Why is this going to make life easy for us? Because now you can think about a sphere. I mean, I'm bad at drawing spheres, but let's say we got these longitudes like this, and then we have the latitude lines. They can nicely create little rectangles for you. And once you can generate all these rectangles, you need to piece them together to form a sphere. Okay. The other reason for giving this assignment is because it will need you to brush up on your geometry and trigonometry stuff. You'll learn all those formulas again, which you have learned already and probably forgot by now. So you'll have to relearn them to draw all these things. Let me come up with a very simple example. Let's say I want to build a cylinder like this, right? The first challenge is to generate all the vertices. So let's say I got a center over here. I need to generate this vertex, I need to generate this vertex, this one and this one, because I need to write the V lines. So can I do this? It shouldn't be a problem if you realize that this is a circle where you just say that I have how many sides to make a polygon, and all these angles are of the same degrees. We have the same angle going on. So let's say I want to build a cylinder out of 32 vertices. Then these angles, the angle will be 360 degrees divided by 32. And once you find this angle, you need to find out these corner points, and they can be easily done with trigonometry if you know that, because the coordinates x and y can be found with x equal to r cos theta and y equal to r sine theta. Okay. So if you know these formulas, the task is not really that difficult. Once you find this out, like we have to have 2 layers of this, one for this and one for over here. So you can change the z height for that. Z equals 0 over here and z equal to h over here. And with that, you can have all the vertices. Then the challenge is to write the faces as they come. So this one is going to be a nice exercise in terms of all the math concept that you have. You need to put them together to write a program. And if you can generate the OBJ files, it's very easy to test. How so? Because you can open Blender, right, and say File, and then go into Import, and there is this option Wavefront OBJ. So whatever OBJ file we are exporting, we can import them. Like this is an OBJ file. It's actually a human character. You can import that, and that thing will appear right over here. Okay. Or yeah, that was not something we covered in class, so let us just go and import something we can relate to. So for example, the monkey, we have seen that before, and this is exported as an OBJ file, and we can import that. So whatever OBJ file your computer program is writing, you should be able to import that as well. Just import that through Blender and check whether you're producing the right thing. Okay. So again, to summarize, what am I asking? I'm asking you to write a program that can read the description from a text file. And in the text file, I'll give you the name of the shape, and along with that, some parameters. So if it's a cube, then the parameter would be the length of a side. If it's a cylinder, I'll give you the base radius followed by the height of the cylinder. Okay? Don't try to do the whole thing at once. Try to take one thing at a time. Let's start with the simplest one. Okay, the cube, right? You have only 8 vertices to work with. You have only 6 faces to work with. So try to write a program that reads this description, 2 or 5 or 10 or whatever the size, the length of a side is. Based on that, you're going to produce a cube in OBJ format. So you're going to write down the vertices. You're going to write down the faces. If you find it difficult to write a computer program first, do it manually. Okay? Open a text file, just write it by hand. Write down the coordinates by hand, test it out in Blender. Now I'm not going to accept that as an assignment, but this is a step. Okay? So try this out. If it works, go and write a program that prints all these lines. Then try to do it with a loop. Try to do it based on parameters. For a cube, you don't really need a loop. Well, it makes life easier, but I mean, it's just printing 8 vertices, printing 6 faces. They're all based on the length of a side. So write that down and see if it loads up properly, and then go from there. If you're done with the cube, then go for the next one, go for the cylinder. Okay. Shouldn't be too difficult. Let us set a deadline for this. How about 2 weeks from now? Actually, yeah, that's going to be let's go for 22, right? 21, maybe we'll have a holiday or not. So to be safe, let's say February 22nd. Is that okay? I mean, there will be plenty of assignments coming your way. For the theory course, we'll have 2 assignments. For the lab course, we'll have 6 assignments. I've talked about that right at the beginning of the course. Is this okay? I mean, if it's not, let me know right away. I don't want to extend the deadline later on. And like I said, the assignments, you can work in a group of 2. That's what I said, I think. Well, you can always work individually. I mean, this is to just give chance to the students who are weak in programming. So if you want to work alone, this is just fine. But yeah, for others, if they want to work in a group of 2, they can. Is the task clear? Okay, so I'm going to post 2 assignments right away on our Google Classroom, and for the remaining time, please get to work. See, we have built this podium today in class, and that was made out of a single cube. Okay, so try to do something similar, and I'll be around. I can go and watch what you're doing, and if you need any help, you can let me know. Okay. Stuff that I want you to try are loop cuts, edge extrusion, and also how to create new faces and how to fix normals. These are the major things I covered today. All right, 3 it is. Uh, Okay, and one important thing, you have to write this program in Java because that's what we picked as language over here. Okay. So these are the 2 assignments that are coming up. I'll stop recording right now, and you guys can get to work. Did you sign in two columns, one for the theory and one for the lab for people who are here? Any? Which one? Center? What do you mean by center? Okay. All right. All right. So you can click with your left mouse button to change the location of the 3D cursor, and if you do so, every time you change the 3D cursor location, if you insert something new, it's going to be inserted at that location, and that can be a bit of a problem. If you want to reposition this 3D cursor right at the center, right over here at 0, 0, 0, you can press Shift S and then cursor to center. That takes your cursor right there, right at the origin. Shift S, cursor to center. Cursor means the 3D cursor. Any other question on the assignments or whatever we have covered today? No? Okay, I'll then stop recording and upload the videos.